Hi all, Coop here, and a bit of a fun one for you today. In this video we are going to look at reading an image file, getting the pixels out of it, and then using that to create a very basic sort of world in our game. This is going to be a very cool and easy to set up little system. It's very easy to do, and it can be expanded on in many ways, hopefully some of which we'll cover in future videos. So I'll try and keep this quick for you guys. The main aim here is basically we have a few images. We're going to read those pixels and we're going to create some objects in our world based off those pixels. I thought I'd do a 3D project for a change, just for a bit of fun. I always work in 2D. You guys must be sick of it by now. So hey, here we go. Let's work in 3D for a change. I'll show you what I have set up in the scene. It's a pretty standard scene. It's just got the camera and the directional light, which I've moved out of the road. We won't be needing them. And I've got an empty game object that I've called image reader, and to that I've attached the read image script that I have here. If you have a look, there's nothing in there. Like normal, I've just left that blank, but I have it there just to make life a bit easier. I have a couple of materials, two to be exact. I've got a brown one that I've called ground, and I've got a grey coloured one that I've called wall. At the moment I'm only working on two colours, two game objects, so we'll have two materials for those. And I've got a couple of prefabs already. The first one is just a standard cube that I've applied the ground material to, so it's a little brown cube there. And the second prefab is just 3 cubes stacked on top of each other, so you can see them there, just 2 cubes as child objects stacked on top of the first one. The wall cube is what I've called it. That just has the wall material applied to it. They're just some basic objects to sort of demonstrate some stuff. If you want to set them up, feel free to follow along at home, sort of thing, but you should be able to use whatever you like. I'm just going to show you the basics here, and it's sort of up to you to adapt that how you like. I've got a saved copy of the scene, which is what it is, and I've got 4 image files here. Now bring them up in Azure. Here we go. So they're pretty straightforward. They're just 64 by 64 pixel sprites with only black and white pixels on them. I'll just sort of show you those now. So they're just some quick things that I knocked up. Cool. So, assuming we have all these things, we'll get started and we'll have a bit of a look. So the idea here is going to be we are going to use one of these image files here to create our world, and we're going to create that world using the 2 prefabs we have, the ground and the walls. So the ground could be represented, I'd say, by the black pixels, and the wall is going to be represented by the white pixels. So we'll have a look at the script. Should be fairly easy to write. I'll do a bit of a demo first. We'll go through the basics. So the first thing we are going to want, just to keep life easy, we're going to have an array of texture 2Ds. So private texture 2D array. We'll just call it images. And we're also going to have a private texture 2D, not an array, just one, and we'll call it image. Nice and easy. Alright, what should we do? I suppose just to demo it first of all, I'll show you the image reading, so actually getting the pixels out of the file, or out of the image, I should say. Okay, so how are we going to do this? Alright, well let's pick one of those images out of the array first. So we'll say that image is going to equal images, the array, and we'll just say pick one at random by using random. Not by using random, by using random.range, and we'll give it 0 and images.length. So that should give us a random image out of that array and save it as image. Now that we've got that, now this is the really complicated part, how we actually get the pixels. If you're ready for this, so we're going to create an array of colors. We'll call it pixels, or maybe just pix. That'll do. And it's just going to equal the image dot get pixels. That's it. So I believe that function, if I remember the manual correctly, it goes from the bottom left of the image to the top right, and it'll do rows along the x-axis of it, along its width. So it'll work from bottom left to bottom right, then it'll go up one, then it'll go sort of left to right, left to right, left to right, until it reaches the top right corner, and it'll give you each one of those pixels as a color in this array, as sort of a flat 2D array. So yeah, you could sort of, if you're iterating through that array, just know that you're going from left to right, bottom to top. Cool, I think I got that right. Let's see. Okay, so probably the first and easiest thing. Let's do a for each loop. Let's just go through that array, and I can sort of show you how it works a little bit better. So for each color, we'll call it C, not X. For each color C in pix, we could just, I suppose, debug log the color, but that's going to have a lot of debug logs. So I'll tell you what, better way to do it. Let's say int black equals 0 and int white equals 0. We're just going to count those. So we'll say if C dot equals, so this is sort of how we can compare the color. So if C equals color dot white, using Unity's color class, I want to call it, object maybe. If C is equal to color dot white, then we're just going to add 1 to the white int. We'll do an else. You could just do an else because there's only 2 colors, but you know, whatever, we'll do it again. Else if C equals color dot black, then we'll add to the black counter instead. Then when it's done, let's just print that out. So we're gonna debug log. What are we debug logging? So we'll just So yep, we're just going to print those 2 numbers out. So it's not giving us the name of the color or anything like that, but it should sort of represent that. So what you can see, we're going through that array of pixels that we got here using get pixels. We're just creating a couple of counters, and every time we find one that is white or is black in that image, we're just going to increment those 2 counters by 1. When we're done with the for each loop, we'll just log the counters to the debug console. And that should give us a rough idea. So there's, what, 64 by 64 sprites. Let's have a look. There you go. So there should be that many pixels in total. Alright, let's have a bit of a look. So we should just get a nice little 2 numbers in the console here, assuming I've done it all. Oh, no, I haven't. I forgot to assign the images. My bad. So if we go to the image reader, we can see their images size. We'll say 4. Just drag those images in, or we can even do it this way, that's probably quicker. Image 3 and image 4. And we'll try that again. Hit play, and if we go to the console, there we go. So 995 pixels, white pixels in whichever image it chose, 3101 black pixels. I have no idea which image it shows. That probably would have been a good idea to print that out as well. But you get the idea. That's the important thing. At least I hope. If I'm doing my job right here, then we should be. Let's expand on this now. So let's see if we can actually make it create something. So we can see how to get pixels. We can see how to figure out what those pixels are, at least in a very basic format. Hopefully from this we can now sort of build something in our game, create a little something. So let's use those prefabs. Let's create a couple of prefabs. We'll create a couple of variables is the word I'm looking for those. What are we using? Private game object, and we'll say what have we got? We've got a wall and a ground. So we'll say wall object and private game object, ground object. I just said the word. You'd think I'd remember it. Okay, so we're basically going to do very similar. We'll get rid of a bunch of this because we'll rewrite what we're doing here. So we still want to grab an image at random. You can use one if you want. I don't know. It's up to you. However you pick the image, but I don't know. I'm just using that for now. What do we want to do? So we grab the image. We get the pixels out of it. Let's work something out. Okay, so we want to generate a very basic world using those objects. So we'll probably want to know the width and the height of that world. Easy to do. We're just going to say that int world x is going to equal image.width. So that just gets the width of that image in pixels, and we're going to repeat the same for the world Z, if I could type. And we're going to do that with image.height. So same thing again. So we should have, in theory, they should both be 64. Those two ints should end up as 64 if we're using 64 by 64 sprites. Doesn't matter, you can use whatever you like, and this should still work. Okay, so normally in my world generators, if I'm doing this sort of looping, and if you've watched one of those videos, you should know what to expect. Normally what I would do is loop through the array, loop through some positions, increment the position, and do everything. Then I'm going to do things a little differently. Let's create an array of every possible spawn position in the world, and we're going to use that to spawn our objects. You'll see, we'll get there. So just work with me on this. Let's create a vector3 array. We'll call it spawn positions. So this is going to equal every possible spawn position to correspond to a pixel. We're going to do that by saying that it's equal to a new vector3 array, and the length of that array is going to be equal to the length of the pixel array, because there should be one spawn position for every one pixel. Let's grab a start position, because we're going to do a loop, and we're going to increase a position each time we do the loop, and then add it to that array. So we'll call it, I don't know, the starting spawn position. We're going to use this as a reference, and we're going to set the starting spawn position, bear with me, sorry guys, to, how are we going to do this? Okay, so let's assume we want the center of our world to be 0, 0, so we want to go from 0 and we want to go to the left, and we want to go sort of back, so we want to decrease the x and the z values to be sort of half our world size minus from 0. So we'll do that by simply halving world size x and world size z and using that, but because we'll end up with some funny values, we're just going to do a mathf.round, and we're going to round world x divided by 2, set the y pos to 0 because we're not going to be using that, and we'll do the same for world z. So we're going to do a mathf round world z divided by 2. So that position should, if you can imagine, you've got the sort of the center point in the world. Let's say, you know, position 0 here. It's basically gonna grab the world size in x and z, and it's going to go back sort of half that here and then half that there. I probably got those axes completely wrong, but you get the idea. It's going to start sort of here and spawn past center, so center should remain centered. Good job, me. Okay, let's have a look. So we've got our start position. What do we need next? We need a vector3 to actually work with in our loops. We're going to call it current spawn pos. So this is the one that's going to increase. In the beginning, we just need it to equal the starting spawn position. Nice and easy. We're going to have a counter as well, because we're going to use this to sort of work out where we are in that pixel array, etc. So just create a new int counter, and it's going to be equal to 0, and we're going to kick off 2 loops. So we're going to do 2 for loops. We'll say for x, what have I done? Oh no, for int x equals 0, because this is going to be the loop for the x coordinate. X equals 0 while x is less than world x. We're going to increase it by 1 each time. And repeat the same for z. So for int z equals 0 while z is less than world z, z increase. Yeah, my American viewers are probably just like, you're saying it all wrong, and I'm like, I don't care. So we're going to set the spawn positions, and we're going to use the counter as the element for that, or the element ID, and it's going to equal the current spawn position. So the very first element in the spawn positions array is going to be the starting position. So the first thing we do in both those loops is we actually set that spawn position in the array, then we increase it. That just ensures that it matches up with our desired size. So we'll increase the counter as well, because we need that to increase by 1 each time this loop does anything special. And we're going to take the current spawn poses x coordinate and increase it by 1. So current spawn pos.x plus 1. Hang on, sorry guys, I made a mistake. This one here, we want to start with the Z. So we're going to loop through Z first. I mean, it really doesn't matter. This probably would have worked anyway, but it's just good to sort of make sure it's all lining up. So we're going to use Z first because, like I said, we're going to loop through the array, and the grid's going to be created from left to right, bottom to top. So the Z coordinate is going to increase each time. So the loop's going to run. It's going to work its way through the X coordinate, and then each time it's run through a whole line on X, it's then going to go up one and repeat the process for X again. So it's going to run the line, go up, run the line, go up, do the next line, that sort of thing. And the same sort of process. So all we're doing is we're just creating a new vector 3 in the spawn positions array. We're incrementing the counter every time it does that, and then we increase the X position by 1. Every time the X loop finishes running, what do we need to do? So we'll want to set the X position to go back to the start. So once we reach the end of the line, it's going to loop back around, go back to the start pos. So we'll set that first. We're going to say that current spawn pos.x is going to equal the starting spawn position.x, just to return it to start, and then we're going to take the Z coordinate, current spawn pos.z, and increase it by 1. Cool, that should work. So that's essentially all we're doing is for every pixel in the array, we are creating a corresponding spawn position for one of our objects. Once we're done with that, we're going to do another loop, probably a for each loop this time, to actually go through that spawn positions array, and we're going to use the counter again, so just reset that back to 0. So once this whole process finishes, counter is going to go back to 0 so we can reuse it, and we're going to say for each. So for each vector 3, which we'll call pos, so for every vector 3 in spawn positions, which is the array we just finished filling with positions, what we're going to do is we're going to say color C equals pix, and we're going to use that counter. So we're using the pix array here. We're just grabbing, oops, not that, what do we want to do? We're just grabbing a color out of it. So the color that we're getting out of that array should correspond with counter, and counter is going to increase each time we check a new position. So hopefully those two should line up. For each pixel, it should line up with the corresponding position in the spawn positions array. Okay, so for that color, we're just going to say, same as we did before, if C equals color dot white, and we'll do the else if again. If C equals color dot black, rightio, and for each time this runs, hang on, what am I doing, counter, so every time this for each loop runs, we're going to just increase that counter. Okay, and every time we come across a white pixel, what do we want to do? We want to instantiate a game object. What did I call it? I called it, was it white object? Something like that? No, it was wall. No, wait, ground. No, wait, white is the wall. Let's do getting there. We're going to instantiate a wall object. We're going to do it at pos at the spawn position that we currently have, and quaternion.identity, just because, and repeat the same thing, just we'll do the ground object instead. I think that was right. So black is the ground object, white is the wall object in our images. Let's just double check that. Oh, there we go, perfect example. Yep, so black would be ground, and white is going to be the walls. So this should be just like a little square wall sticking up out of the terrain. Okay, I think that's the script. Sorry, let's have a quick look at that again. I don't think I'm missing anything there. So just to run through it very, very quickly as I do, we've got our variables up here, the image array and the image itself that we're going to select from that array, and the two prefabs, the wall and the ground. When the script starts, it's going to grab one of the images randomly out of that array, get the pixels out of it and store it to an array of colors. It's then going to use that image to determine a world size in X and Z coordinates, the width and the height of the image. We then create an array of an empty array of spawn positions, which is equal to the length of the pixels array. We then create a starting spawn position using the values of the world X and the world Z, and we then set a starting or a spawn position that we are going to work with to equal the starting spawn position. We have our counter. We run through 2 loops, so this is looping in a grid sort of pattern, left to right, bottom to top. Each time it loops, we just create a new position in the spawn positions array using the counter, and we then increase all the values that we need to sort of keep looping that position through the grid. Reset the counter, then we go through the spawn positions array, we grab each position in it, and for each position we check the corresponding pixel on the image. If it's white, we spawn a wall. If it's black, we spawn a ground object, and then we increase our counter. That should be it. Let's test it out. Hopefully we should get a world or something, you know, a thing of some kind. We won't though, because I've totally forgotten to set the game object variables when Unity catches up. I'll do that. So there we go. I'm going to set the wall prefab and the ground prefab. Cool. Let's try that again. Let's hit play, and we should just get a little world or a little thing built from our image if I haven't done it wrong. Hey! Look at that. If we restart the game, hopefully it'll pick a different image. Probably won't, just to spite me. See if I can get a couple more to come up here. There we go. You sort of get the idea. So that's very basic functionality. That's just reading from an image. It's using the images that we already have in the scene. There's a couple of points about those actually that I should have probably covered. Let's have a quick look. So these images have actually been set to sprite, 2D and UI. The pixels per unit for them all should actually be 64. Doesn't really matter. What did we set? The filter mode. Make sure that's off, otherwise you might get a bit of blurring and it'll confuse the system. And you'll probably want to also tick this box, read, write, enabled. If you don't have that, because it usually isn't by default, and you try and do it, you'll get errors about being unable to read the image. There we go. So texture image 1 is not readable, texture memory cannot be accessed from scripts, blah 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 blah. That is just complaining because those images need the read write enabled in order to work. I've got the max size set to 64, the compression none. Otherwise they should be pretty straightforward. So that should be all there is to it, guys. I hope this has helped you out. And what with the new changes to YouTube and the new requirements, it's more important than ever that I ask you, hey, if you like my work, please subscribe, please like these videos, it really helps me out. Thank you to all my Patreon supporters, you guys are fantastic as always. I'm going to start trying some cool things to put your name on these videos, so if you're embarrassed by that, sorry. But yeah, thanks for stopping past, and hopefully I'll see you guys in some future tutorials when we talk about some other fun stuff. See you later.